Hello everybody, this is Amel, and today I'm going to show you how to write binary search. So given a sorted integer array nums of n elements and the target value, write a function to search target in nums. If target exists, then return its index, otherwise return -1. So as you can see, in this example number 1, they give you this array that is sorted in ascending order, and they want you to find the target, which is 9. So you return 4 because 9 is at index 4 in this array. Example 2, they want you to find target, which is 2. So 2 is not in this array, so you return -1 to indicate that it is not present in the array. So a naive way to solve this problem would be to use a linear search. So you would go from left to right looking for the target. When you find it, you return its index. If you didn't find it, you return -1. That would take big O n time. But can we do better? Yes, we can do better. As the title suggests, we can use binary search. Because the array is sorted, we can always use binary search to find that element in logarithmic time, or big O log n time. So what we do is that we find the middle element, we check. If the middle element is the same as the target, I'm done, and I return the index of the middle element. If that's not the case, I check. If the middle element is less than what I'm looking for, then I know that all the elements, including the middle element, are less than what I'm looking for. So I can discard the left part of the array and only focus on the right part. By the same token, if the number that I'm looking for is actually less than the middle element, then I know that all the numbers to the right, and also including the middle element, are bigger than what I'm looking for, so I can discard the right part and only focus on the left part. And by reducing the search space in this manner, every iteration or every recursive call, then I know that I can find the target value in logarithmic time, because I'm always dividing the search space in half. So without further ado, I'm going to show you how to write binary search. So first, I need to have two pointers, one at the beginning and one at the end. So int left gets a value of 0, int right gets a value of nums.length -1. And then I can do this iteratively or recursively, but the iterative solution is more efficient because it doesn't use the recursive stack. So I'm going to show you how to do it iteratively here. But it is also okay to do it recursively. So while left is less than or equal to right, this condition says, okay, I want to continue looping as long as I'm looking at two different elements, or as long as I'm looking at one element. Because if I'm looking at one element, that could still be the one I'm looking for. So that's why I have to put the equal sign. It has to be less than or equal to right. So I calculate the middle index. Integer mid gets a value of left plus right divided by 2. And this is fine here. Left plus right divided by 2. But there's a better way to do this. And it is saying left plus right minus left divided by 2. Why? Well, because when you are adding two big numbers, you might get overflow. But by doing this here, you can avoid that condition and be safer. So that's why this is the more professional way to do it. So now that I have the middle index, I can compare and check if the element that I'm looking for is the same as the one at the position middle. If nums, so mid, equals the target I'm looking for, then I'm done, and I return its index, which is mid. If that's not the case, then I have to check if I have to consider only the left or the right part of the array. So else if num sub mid is less than the number I'm looking for, then that means that the target has to be to the right, because all the numbers to the left are smaller, including mid. So I can discard the left part by adjusting the left pointer. So left gets a value of mid plus 1. Else is the opposite condition. That means that the target has to be to the left. So I can discard the right part by adjusting the right pointer. Right gets a value of mid -1. And if I go through the entire array doing the binary search and I don't find the element that I'm looking for, that means that I'm gonna break out of the while loop. That means that the element was not there. I just want to return -1 to indicate that the element was not found. So I'm gonna run the code. Okay, so it seems to be working perfectly. Submitting the code, and as you can see, it is working perfectly. So this is binary search. The time complexity is big O log n. Please press the like button. Don't forget to subscribe, and see you next time.